Hello and welcome to another lecture on analog electronics. Today we'll be talking about voltage amplifiers. An amplifier is characterized by three parameters. The first one being the input impedance Ri, the output impedance R0, and a gain. And in case of a voltage amplifier, this is a voltage gain. That is, if we apply an input Vi, then the output of the amplifier would be V naught is equal to AV times Vi. So this circuit diagram here is a Thevenin equivalent representation of a voltage amplifier. We have a source voltage Vs in series with its source impedance Rs. So this part of the circuit represents the source, and this part of the circuit represents the load. We have connected a resistance RL, and here in between we have the amplifier. The voltage across the input impedance is Vi. So this voltage source AV times Vi represents an amplification of the voltage Vi across the input impedance. So we know from voltage division that the voltage Vi across the input impedance is given by Ri over Ri plus Rs times Vs. Now ideally for a voltage amplifier we would like that Ri, the input impedance, is equal to infinity. So for the ideal case where the input impedance is infinity, we can assume that these 2 points are open. Therefore, whatever the voltage Vs is, the source voltage, comes across these two terminals of the input impedance. So we can write that Vi is equal to Vs under ideal conditions. Since when Ri is infinity, no current is drawn by the source, and hence all of the input voltage Vs appears across the input impedance Ri. Similarly, at the output, we can write that V naught, the voltage across the load resistance RL, can be written as RL divided by R naught plus RL times AV times Vi. In this case, we would like the output impedance R naught to be equal to 0. So if we put R naught equal to 0 in this expression, we get V naught is equal to RL over RL times AV times Vi. Thus the output voltage is equal to AV times Vi, and Vi we have just seen equals Vs under ideal conditions. Therefore the output voltage V naught is equal to AV times Vi under ideal conditions. So this expression of an ideal voltage amplifier states that regardless of the values of Rs, source resistance, and RL, the load resistance, the output voltage is simply governed by the amplification factor AV, and given an input voltage Vi, this should be Vs. So given an input voltage Vs, we can simply get an output voltage by multiplying the input voltage by this gain called the voltage gain in this case. AV. Now, in reality, we know that it is not possible for the input impedance of the amplifier to be infinity as well as for the output impedance to be zero. Therefore, so to approach ideal conditions, we would like to have Ri much greater than the source resistance Rs. Similarly, R naught to be much less than the load resistance RL. So these two conditions, if they are met, then we would approach an ideal voltage amplifier. So that's it for today's lecture. In the next lecture, we'll see current amplifier, another category of amplifier, and we will continue our lecture series.